Esteemed panel of respected judges, I am Sandeep Basir.
I am Darshana.
We are 600 students from Kendriya Vidyalaya number 1, Palakkad, Kerala. We are very thankful for the organizers for giving us an opportunity to present before you our project in Phase 2 Adult Tinkering Marathon. Our project is Automatic Irrigation Control System, submitted under the focus area Agri. In Palakkad, 70% of the people are engaged in paddy cultivation. Effective use of water is important in agriculture to get maximum output. In Palakkad, agriculture depends on irrigation system and water is scarce. In rainy season, water is collected in tanks. During summer, water is released through canals by opening shutters near dam. Water is distributed through branch canals to the paddy fields by opening walls on the sides of canals. The walls are opened and closed without taking any feedback. To study this problem, we met farmers in Palakkad district.
Uncle, എങ്ങനെയാണ് കൃഷിയിടം നനയ്ക്കുന്നത്?
ഡാമിൽ നിന്നും വെള്ളം കനാൽ വഴി കിട്ടും. അതുപയോഗിച്ചാണ് കൃഷി നടത്തുന്നത്.
ആവശ്യത്തിന് വെള്ളം വേണ്ടപ്പോഴൊക്കെ കിട്ടുന്നുണ്ടോ?
മണ്ണിന്റെ സ്ഥിതിവിവരം മനസ്സിലാക്കുന്നില്ല. അതില്ലാതെയാണ് വാൽവുകൾ തുറക്കുന്നത്.
നമുക്ക് ഈ പ്രശ്നം എങ്ങനെ പരിഹരിക്കാം?
മണ്ണിന്റെ സ്ഥിതിവിവരം, അതായത് ഉണങ്ങിയതാണോ ഈർപ്പമുള്ളതാണോ എന്ന് മനസ്സിലാക്കി വാൽവുകൾ തുറന്നാൽ ഇത് പ്രയോജനകരമാകുന്നതാണ്.
According to the farmers, problem they face is the water is supplied to large area without assessing the soil condition. We collected the details from present system. Water supply is regulated manually by controlling valves on the sides of the canal. It is done after taking feedback and suggestions from farmers and based on the past experience. The decisions are taken in advance so the present system is not efficient. We have proposed an innovative system. Paddy field is divided into sections of same level. Sensors are used to monitor soil conditions and they are connected to an electronic control device in each section. It regulates the water flow by controlling the wall based on the input from sensors. This system saves precious water, especially in the summer. The proposed system is more efficient compared to the present system. This is the block diagram of the proposed system. The system consists of 2 sensors, an electronic control device and a wall. The principle of the proposed system is that we have to sense the dry and wet conditions of the soil in real time. Water is supplied to the field when soil is dry and water supply is to be stopped when the soil is wet. Also, the water supply is to be regulated based on temperature of the atmosphere. To verify the effectiveness of the system, we have developed a prototype of automatic irrigation control system using the facilities available in adult tinkering lab of our school. The prototype consists of small irrigated area representing the paddy field, humidity sensor which senses the wet and dry condition of the soil, temperature sensor which senses the atmospheric temperature, water tank where water is stored, motor pump arrangement for the controlled supply of water to the field, Arduino board, an electronic device which acts as a control to start and stop the motor, GSM module for wireless communication. Now we will show the working of the prototype. 1 temperature sensor and 2 humidity sensor. One sense heat and other moisture. When sun is bright, sensor 1 opens water supply.
When it drains, the sensor too closes the water supply. An electronic device receives signals and sends commands to control a motor to regulate the water supply.
Humidity sensor, which senses the wet and dry condition of the soil and sends signals to the Arduino board. Temperature sensor, which senses the atmospheric temperature and sends signals to the Arduino board. Arduino board is programmed to switch on the motor when dry condition is sensed. It switches off the motor pump when wet condition is identified. Similarly, based on the input from temperature sensor, the controller switches on the motor when temperature is high. Developments that are affected on the prototype. GSM module is connected to the Arduino board. This has helped to establish communication between a system and farmers. Farmers can get various data regarding the operation of the system through SMS. Farmers can remotely control the set values of operation of motors. The period of operation of the motors can be monitored, thereby the total quantity of water flow can be calculated.
Additional improvements possible are
A flow sensor can be connected to measure the flow rate. Controlled feeding of nutrition and fertilizers through water line can be effected.
future possibilities are
New trends and systems in agriculture are implemented to maximize the production, reduce wastage and optimize use of water, fertilizers, etc. The introduction of electronics in agriculture for remote monitoring, creating controlled climatic conditions, water line feeding of nutrition have produced encouraging results. Many large companies such as TCS, UST Global are engaged in activities agriculture integrated with computer and electronics in their research on Internet of Things. We hope our system can be adapted with necessary modification by Irrigation Department, agriculture research institutions and industries. Thank you for patient hearing.